All right, let's get started. Hello, everyone. First of all, thanks for being here so early. I think it's the first talk after the keynote. So it's impressive that you made it here after the party last night, if you've been there. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, but I always try to come to NDC also because I love this conference. It's one of my favorite conferences. Maybe you realize Google Cloud has a booth at the entrance with cool swag and cold labs, and we also have a raffle at 1 p.m. for Google Home Mini, so feel free to stop by. I'll be there as well. Today I'm going to be talking about Knative. This talk is designed for 40 minutes or so, but we have 1 hour, so feel free to stop me at any time if you have any questions. I like this to be interactive if possible, but I can't really see you, so if you have a question, just yell so that I make sure that I see you, because these lights are right in my face. And also one thing to mention, the slides and the code, it's already on GitHub. So if you go to my GitHub link, and this is the QR code, everything's already there, so you don't have to keep taking pictures. This is the only picture that you have to take. Before I start my talk, I always talk about Google Cloud for startups because I like to help startups. So if you are part of a startup or if you are thinking of doing your own startup, just keep in mind that Google Cloud has a startup program where you can get $3,000, $20,000, or $100,000 free credits if you are interested. And this is the link. So if you go to this link, you can start with $3,000 free credit if your startup is eligible. I always mention this because I like the idea of startups, and I like you to know that we like to support startups at Google Cloud. All right, let's get started with Knative. Who here heard of Knative before or uses Knative? Okay. So what I'm assuming here is that you either know or use containers, and you either know or use something like Kubernetes to manage your containers, and you're also interested in serverless world and running serverless in your Kubernetes platform. So you probably heard of Knative, but you don't know exactly what it is or what it provides, and hopefully this talk will give you all the introduction to Knative. So it's an intro-level talk, but at the same time, we will go through a lot of different parts of Knative. It's very demo-driven. At the beginning, I'll do a little bit of introduction with a few slides, but after that, it will be very much like demo-driven kind of talk. And as we go along, as I mentioned, feel free to stop me and ask me any questions that you have. First of all, what is Knative? Knative, it's Kubernetes-based open source building blocks for serverless. And if you know anything about Kubernetes, you know that it doesn't make sense to talk about Kubernetes and serverless in the same sentence, because Kubernetes it's all about scheduling containers on actual nodes, right? And these nodes are either virtual machines or they're physical machines, but they're servers. And they're servers that you have to think about. And if you're not using a managed platform like Google Kubernetes Engine, you need to think about them, you need to maintain them. So there's nothing serverless about Kubernetes, but that's the whole point of Knative. Knative tries to make Kubernetes a serverless platform, and that's what I'm going to explain here today in this talk. Now, of course, we need to define what we mean by serverless. So depending on who you talk to, you get different definitions of serverless. Some people define it as functions, and that's it. And some people define it as basically anything that you don't have to maintain as serverless. For me, when I think about an ideal serverless framework, first of all, I don't have to think about servers, obviously. There's a server somewhere, and someone has to maintain them, but ideally, it shouldn't be my problem if I'm using a serverless framework. Secondly, I like my serverless framework to be idiomatic. For example, I'm a C#.NET developer, so I'm used to using ASP.NET Core Web APIs. So I should be able to use that in my serverless framework. Or if you are a Java person, you should be able to use Spring Boot because that's what you're used to, right? So ideally, you want your serverless framework to support the tools and languages that you're already using. Whenever we talk about serverless, it's usually event-driven. So something usually triggers your container or triggers your function. So it's kind of asynchronous rather than synchronous. And it's also nice if the serverless framework is portable, meaning if you deployed your serverless function or your serverless container to one platform, like Google Cloud, ideally you should be able to take it and deploy it to other places as well. You shouldn't have to rewrite at least too much to move things around. So Knative, I think it does a pretty good job of supporting all these features that I look in a serverless framework. Now, for those of you who might not know Kubernetes, just a single slide to cover what Kubernetes is. So Kubernetes is all about scheduling and running containers. So what you do is you first define an image for your code. So your code lives in a public repository like Docker Hub or Google Container Registry. Then from there, you create what's called a pod template. A pod it's a single unit that gets scheduled in Kubernetes. It's usually a single container, but it can be multiple containers scheduled together as well. Then you tell Kubernetes what you want to be true. In this case, we want to have 3 replicas of these pods. So Kubernetes will look at your pod template and will create 3 pods, and it will schedule them onto the nodes that you have. So these nodes are either virtual machines or physical machines if you're running Kubernetes locally. Then once your pods are running, you can label them, and then you can group them into what's called Kubernetes services. These services, they have stable virtual IPs, and they can have domain names as well. And people from outside will get to your service, and from there, will get to your pods and your code running in the pods. So in this containerized Kubernetes world, a microservice ends up being a combination of your code coupled with what Kubernetes provides with replication controllers, services, pods, and all that kind of stuff. So Kubernetes is great for running containers at scale because it provides this high-level API and a framework to run containers at scale. But as developers, we don't care. At least we shouldn't care, because when you're a developer, you're trying to solve a business problem, and you're trying to write code to solve that. Ideally, all these details about running your code should be abstracted away from you, right? So on one hand, we have developers who don't want to care about this stuff. On the other hand, we have operators who love Kubernetes because it provides this framework and this high-level APIs to manage containers. So there's this tension, basically, between developers and operators. And Knative tries to solve this tension. So the whole point of Knative is that it tries to turn Kubernetes into a serverless platform so that the developers using the platform, they don't have to care about the underlying Kubernetes. But operators, they can still use Kubernetes, and they can still enforce things that Kubernetes helps with. So the Knative is on GitHub. It's an open source project. It started from Google, but now a bunch of companies like Red Hat and IBM and SAP and Pivotal there, and many more, they're supporting it. By the way, maybe I should combine Red Hat and IBM into IBM now that IBM bought Red Hat. But anyway, it's a set of components, serving, eventing, and build that we'll go through. And it basically came from Google. Like, so all the things that we used and learned from Google, we kind of open sourced it into Knative. And for those of you who used Google Cloud before, if you use App Engine, you will see some of the concepts of App Engine kind of bleeding into Knative. Like, for example, versioning and traffic splitting, stuff like that, they are now open sourced into Knative. So some of the things that I was used to on App Engine, I was pleasantly surprised to see in Knative. So the Knative stack, it kind of looks like this. The underlying platform is Kubernetes, so you're running on Kubernetes. On top of that, Knative doesn't really deal with the networking layer. Instead, it relies on a gateway. By default, it uses Istio as the gateway to figure out the traffic rules and all the traffic details. But in the latest version of Knative, which is 0.6, they added support for Glue. Anyone here knows or uses Glue? No? A little bit? OK. I don't know anything, because I never used it. But apparently, it's a lightweight gateway. So the thing about Istio is that it's a great gateway. It provides a lot of features, but it's kind of heavyweight. You need to have a few, like, for example, if you want to run Kubernetes and Istio in Google Cloud, you probably need at least 3 or 4 nodes. So because of that, some people find it a little bit heavyweight, and now there's support for Glue, which is supposedly much more lightweight than Istio. But the thing about Glue is that if you use Glue with Knative, it doesn't support Kinetic Eventing yet. So you need to keep that in mind. So either way, so you have your Kubernetes running, you have your networking handled by Istio or Glue, and on top of that, you install Knative. So Knative has 3 parts: build, serving, and eventing. You can install them separately, like one by one, or you can install them all at once if you want. So you don't have to use them all at once. It's basically up to you to pick and choose which part you want. And then on top of that, there are products that are being built on top of Knative. For example, on Google Cloud, there's something called Google Cloud Run, which is a managed version of Knative on Google Cloud. There's something called Google Cloud Run on GKE, which is the managed version of Knative, but on Google Kubernetes Engine. So if you want to stay in Kubernetes ecosystem, you can still use Google Cloud Run on GKE. And there's other products from other companies that are being built on top of Knative. So the idea is that you would use Knative as the underlying platform, but then you would for the developer experience, you would use the product from the company that you're using. So if you're on Google Cloud, it probably makes sense to use Google Cloud Run because it's much more managed and much more user-friendly than using Knative itself. But this talk is about Knative, so I'll show you how to install Knative and how to run Knative as if you're doing it yourself. And I'll show a small demo of Google Cloud Run so that you get an idea of the developer experience on Google Cloud Run as well, okay? So how do you use Knative? First of all, you need a Kubernetes cluster. So depending on where you are, there's different ways of setting up a Kubernetes cluster, but on Google Cloud, you would use a gcloud command line tool to create a cluster. So here I'm saying I want to create a cluster. This is my name of the cluster. And I'm saying that I want add-ons, and one of the add-ons is Istio. So when I create my cluster, Istio will also be installed for me with this, so I don't have to install Istio separately. And then I specify some things like the machine type and the cluster version and the zone where I want my cluster. So eventually I have a cluster. So this is a typical Kubernetes cluster with Istio already installed. And then I need to create a cluster role binding so that Knative and Istio can manage the traffic within my cluster. So that's what the cluster role binding is all about. And then after that, you install Knative. So in this case, I'm using 0.6.0, which is the latest version of Knative. And it comes with YAML files for it. So if you want to install serving, you would point to serving YAML file. If you want to install build, you would point to build YAML file. So this is how you would install the full version of Knative. But you can also pick and choose parts of Knative and install just those as well. So in the end, what you end up having is, let me show you my console. So here I'm in Google Cloud Console. I already created a GKE, Google Kubernetes Engine cluster. I already have Istio installed. I already have Knative installed as well. And just to make sure that things are working, I can go and say kubectl get pods. And then everything gets installed under separate namespaces. So here I'm saying, let me look at the pods of Knative serving namespace. And let's make sure that they're running. So they are. And then let's look at Knative Eventing. Those are running as well. And then let's look at Knative build. So those are running as well. So everything is running. So we can actually proceed with our presentation and then look at the demos later. So let's first talk about the first part of Knative serving. So what is Knative serving? It basically enables you to deploy a container in a serverless way. That's how I explain it. And what I mean by that is you basically create a service definition file for your Knative service, and you point to your container that you want to deploy. And then what Knative does is that it deploys a container, it sets up all the traffic to the container, so all the traffic details of how people get to your container is already set up because of Istio. And then by default, your container will run on a single pod, but it will automatically scale up and down. So if no one uses it, within 60 seconds, it will scale down to 0. If more people use it, then it will scale up to n that you define, so you have automatic scaling. Then every time you deploy your container, you get a new revision. So you will have new revision every single time. And with that revision, you also have configuration for each revision. And then once you have the revisions, by default, each revision will get all the traffic, but you can set rules so that you can do traffic splitting. So you can do things like, the latest version gets 50% of the traffic, the newest version gets the other 50% as well. So basically, it enables you to deploy a container and get traffic set up to the container, get auto-scaling set up for the container, get revision management, and get traffic splitting between those revision managements, right? So that's what Knative serving is in a nutshell. And the terminology of Knative serving, I already explained this a little bit, but just to go over again. At the top level, you define a Knative service. This is not a Kubernetes service, by the way. It's Knative service. And your service will have a configuration where you point your image, and you also have some configuration like environment variables for your container and things like that. And once you deploy your service with its configuration, it will create a revision for your service, and it will create a route that points to that revision. So by default, the latest revision will get all the traffic. Now, if you change anything about the configuration here, like changing the image or changing the environment variable, it will create a new revision, and it will point the route to that revision, right? But you can also set rules here in the middle here so that you can do traffic splitting. So the primitives of Knative serving is that service, configuration, revision, and route that points to the revision that you want. So let's take a look at some examples of this. And As I mentioned, all of this is on my GitHub as Knative tutorial, and I will refer to this tutorial as we go along. So first, I want to show you the hello world example, so we get an understanding of how that looks like. By the way, all my samples are extremely simple because I always try to find the simplest example that I can show you to get the point across. Because sometimes you see some examples where it's like too complicated and you're trying to understand what's happening. So for that reason, I keep my examples really simple. So what I'm doing here is that I'm writing a simple C# hello world application that will just, when it gets a request, it will read an environment variable and it will just echo back and say hello world with that. So I create the service. I won't show you the code because it's really simple. It just says hello world. Then I build an image and push it to Docker Hub. And then what we need to do is we need to create a service YAML file. So this is the service definition for my Knative service. The first thing that you're going to realize is that this is the API. This is the Knative API, and the type is service. Then you give your service a name, and you define which namespace this service should live in. So in this case, it's default name service. And then you define the configuration of your service. First, here we are saying run latest. What this means is that when I deploy this service, it will get all of the traffic. It will get 100% of the traffic. And then under the configuration, we point to the image that we push. So it points to my image on Docker Hub. And then I am also passing the environment variable with the name target and the value is v1. So it will read this target environment variable, and it will just say hello world v1. So that's what my service does. So we will apply the service, and then we'll look at the pod, the Knative service, the Knative configuration, the Knative revision, and the Knative route as we create things. So let's do that. So let me first watch things. Make this a little bit bigger. You will realize that I have some pods running. These are for pods that will read some events later that I'm going to show you, so you can ignore them for now. They're not relevant for this example, but I created them because it takes a little bit of time to create them for the next example. But here I am in Hello World section, and then I have a bunch of service definition ones, and I want to apply the first one. So let's apply service v1. So this creates a Hello World service, and you'll realize that immediately we have a pod that's been created, that's already running. We have a Knative service that's been created. We have a configuration for the service. We have a revision, which is the first version of the revision. And we also have a route that's pointing to that revision. So everything is already up and running. But how do we get to the service, right? We need to go through Istio, because Istio is the one managing the traffic to the cluster. And in Istio, there's something called Istio Gateway. Istio Gateway is basically an external IP that manages all the traffic into the cluster. So we need to find the Istio ingress gateway, and then we need to curl to that IP, but we need to specify which service we want to get to, right? Because you can have multiple services under the same IP. So in this case, I'm saying I want to get to the Hello World service in the default namespace, and this example.com is the default domain in Knative. So that's how you could get to your service if you haven't configured your own domain. Now, in the next section of my tutorial, I show you how to set up the domain. I won't bore you with the details. And for the demo, what I did is that I used something called nip.io. Nip.io is a dummy domain service that enables you to basically map things like this, like 10.0.0.1 nip.io maps to an IP. So I use this as my domain service so that I don't have to set up a real domain. And once I did that, and I explained how to do this here, you can do a curl like this, as if I have a domain. And let's go back here and do a curl. And you see that it says hello v1, so our service is running, right? So basically, deploying a container is just like a service YAML, just deploy, and everything is set up for me. Now, every time I change something about the service, it creates a new revision. For example, let's say we want to change the environment variable. So here, instead of saying target and the value is v1, let's say we say v2, we change that. Once we do that, let's do it and see what happens. So I'm applying the version 2. You'll see that it immediately creates a new revision. So this is the second revision. And then it immediately creates a pod. So now I have 2 different pods running. And it updated the configuration, the route. We don't see the route here, but let me see, make it a little bigger. So the route, well, it's down here, but the route is updated to the latest revision. And if I do a curl to the same URL, now it says hello v2. So we updated our service with the new configuration. Now, if you want to update the code, it's the same way. So the code updates basically I change my code, and instead of saying hello, let's say I want to say bye right now. I change my code. I create a new image. Now this image is version 3 instead of version 1. Then I come to my configuration, and in the configuration, I change my image. Instead of saying v1, now I point to version 3 image and apply the service. And let's do that. So once I do that, again, this will create. Now, one thing to realize is that one of the pods is terminating because it's the first revision that we haven't used in the last 60 seconds, and because of that, it's scaling down to 0, right? So it does auto-scaling for me automatically. So version 1 is scaling down to 0, version 2 is running, and version 3 with the code change is running as well. And now you can see that I have 3 revisions, and if I do a curl to the same URL, now it says bye v3. So we updated our code, right? But as you know, in the real world, you wouldn't update code just like that. What you would do is that you would maybe deploy a new revision and maybe let it get, say, 20% of the traffic and see if it works. And if it works, then you would gradually scale up to 100%. So you want to do like red, green deployments or traffic splitting or whatever you want to call it. You can do that in Knative. What you need to do for that is you need to go to your service, and instead of doing run latest, because we were doing run latest, which means it will get all the traffic by default, instead of that, we'll do a release. And in this release, we will refer to some revisions. So in this case, we're saying I want to do a release with revision 1 and revision 4. And I want the revision 4 to get 20% of the traffic. So this is what this means. So the revision 1 is the one that's already deployed. Revision 4 is the one that I want to deploy here. And this 20 is the 20% is for this new revision. And this configuration here is the configuration of this new revision. It's a little bit confusing, and they're making this a little bit easier. But for now, this is what you need to do, basically. The configuration is for the new revision. The rollout person is for the new revision. And this is for the old revision. So if you do this, let's do that. Oh, and then one thing I forgot is that if you look at our revision numbers, they're not actually 1 or 4. They're more like hash codes. So I need to actually do a proper release with this proper name. So I should copy this and come back here. Instead of 1, let's make this the proper name. And then for the 4th, let's copy this one. And then do this one. Now, if I apply it, it should update my revisions and my traffic. And let's do some curl commands. So let's do a loop here so that we can see traffic splitting. So I'm doing here a loop or curl like 10 times. And let's see what happens. Now you see that there's container creating, so it's probably hitting version 1. And now it's version 4. It's version 1, version 4, version 4. It looks like it's 50%, but now it's mostly version 1. Yeah. So most of the times it should be version 1, which is the case now. So we did like 80% to 20% traffic splitting between an existing revision and a new revision, right? Now, if you want to do traffic splitting, where's my, between 2 existing revisions, you can do that as well. So you come to your service, and then in the revisions, you basically point to the revisions that you already deployed. And once you apply this, it will just do traffic splitting, like 50% traffic splitting between the existing revisions that you have. So that's how you can do traffic splitting in Knative. Now, this auto-scaling, like scaling down to 0 and scaling up to n, is all configurable. And the actual auto-scaling type is also configurable. So let me show you how that works. But before I do that, let me deploy a service. And let's try to load the service. And in the meantime, I'll explain you auto-scaling. And then we can come to our service and see that it's actually auto-scaled. So what I'm doing here is that I created a new service called a sleeping service, because it's just gets a request and sleeps for 4 seconds, like simulating traffic, like doing some work. And then what I'm going to do is that I'm going to change auto-scaling so that it doesn't, so it will have concurrency 1. And then we'll hit this service, and we'll see that it will scale up to 5. But before I explain it, let me just deploy this and also copy this 4TL load. So let's copy this. And let's go to sleeping service, and then first of all, let me delete my hello world service. So as you can see, once I deleted, everything is gone, and these are terminating already. Now let's apply the sleeping service. So now the sleeping service is created. And now let's try to load this service, send some traffic to it. So I'm going to use a tool called Fortio, which is a load testing tool. And I'm just going to send some traffic to that. So we'll just let that run. As you can see right now, there's only one pod running. But hopefully, when I come back, it will scale up to 5 that I set as the maximum. But in the meantime, I can explain you the auto-scaling configuration. So the configuration for auto-scaling is basically, it's under service. And then by default, this is the auto-scaling configuration that you have. So the class auto-scaling is, the metric of auto-scaling is concurrency, meaning each pod will get 100. It's 1 here, but the default is 100. It will get 100 concurrent requests before it scales up, right? That's the default. You can change this number. So in this case, for my sleeping service, I change it to 1, meaning I only have 1 request coming in, and then it will scale up so that I can show you auto-scaling. But this is configurable. And also, the type of auto-scaling is configurable. So if you don't want to do concurrency-based auto-scaling, but you need to do CPU-based auto-scaling, you just comment this out, and then you just comment this in the CPU, and it will do CPU-based auto-scaling. And this is based on Kubernetes' CPU-based auto-scaling. The minimum and the maximum is also configurable. By default, minimum scale is 0, meaning your pod will scale down to 0 if no one uses it in 60 seconds. But you can set it to 1, and that way you will always have 1 pod running no matter what. And you can also set to a max. In this case, I set it to 5 so that I won't have more than 5 pods running at all times. And also, this auto-scaling is also configurable in the sense that you can write your own auto-scaler, and you can plug it into your auto-scaler here as well. So you can write code to do auto-scaling your way if this doesn't work for you. So that's how we can do auto-scaling. And so we deployed our sleeping service. We are loading it. And if everything works, yeah, as you can see, we have 5 sleeping services running because the Fortio is loading them. So let me just stop it now. And then within a few well, not a few seconds, but within a minute or so, these sleeping services will scale down to 0. Okay? So that's auto-scaling. And also, the nice thing about Knative is that you can actually integrate with anything you want, because in the end, you have a container with a public URL, and anyone who can call the URL can get your container. So what I did is that I really like Twilio. Anyone here heard of or uses Twilio for anything? Yeah? So Twilio, for those of you who might not know, it's a framework, it's a service to write phone or SMS applications. And what you can do is you can get a phone number from Twilio. At least in the UK, you can get it for free. And then you can say, when someone calls me on this number, make a call to this endpoint. When someone sends me a text on that number, make a call to this endpoint. So what I did is that I got a Twilio number. So this is my UK number in Twilio. Feel free to call this number or text it if you want, because I'm not going to be the one answering it. It will be Knative who's going to answer it. But basically, once you have this number, you can say, if someone calls me, call this endpoint. I didn't change this. This is Twilio's default endpoint. And then if someone sends me a message, call this endpoint. Now, in this case, you can see that I'm calling my dummy nib.io endpoint, and it's /SMS. So it's going to call my SMS controller that I deployed. And then just to give you an idea how this looks like, it's something very simple. I created a Hello World app in ASP.NET, and then in here I created an SMS controller. I'm using Twilio's NuGet libraries, and I'm saying when someone calls me on this endpoint /SMS, create a response, and then just say Knative copycat says, and then just reply back with the message. So basically, I'll receive the message, and I'll just reply back with that message. So that's all it takes to reply back to an SMS. Then I create a Docker file. Then I push it to Docker Hub in here. Then I create my service definition file just like before, but now I'm pointing to my Twilio image. And then I apply my service, and let's see what happens actually. So by the way, you can see that my sleeping service is scaled down to 0. So let's just delete that too. Delete. All right. And now let's go to Twilio. Apply the service. Now this should create my Twilio service, hopefully, and then it's running. Then I can go to these are my messages on my phone. You can see my messages. And this is my Twilio number. So what I'm going to do is I'm going to say, hello from NDC Oslo. So I'm sending a message from my phone to my Twilio number. This will go to Twilio. Twilio will make a call to my Knative endpoint. My Knative endpoint will wake up. It will, hopefully, yes, it will say, the Knative copycat says, hello from NDC Oslo. So we'll get the message reply back. And then when no one replies back, when no one sends a message for 60 seconds, it will scale down to 0. So you can see that you can pretty much integrate with anything you want because it's basically in the end a public endpoint that you can use. All right, let's see if I want to show anything else with Knative serving. Oh yeah, and one thing that I want to show is that so far, what I've shown you is Knative everywhere. So every time you have a Kubernetes cluster, whether it's running locally, whether it's running on Google Cloud or Azure, you can have all of this so far. But if you're on Google Cloud, you would use something called Google Cloud Run, which is a managed version of Knative. So what I want to do is I want to show you here the user experience with Google Cloud Run so that you get an idea of how that works on Google Cloud. So the thing about Google Cloud Run is that it's something that we just announced recently, like a couple months ago. And because of that, it's only available in US Central, but it will be available everywhere pretty soon. So first, what I need to do is I need to switch to my project in US Central. Let me do that before I forget. And then the second thing I need to do is that Google Cloud Run doesn't support Docker Hub yet. It will. So because of that, I need to submit my image to Google Container Registry. It's like Docker Hub, but it's for Google Cloud projects. So what I'm doing here is that I'm running this gcloud command line, and I'm saying, this is my submit my build. So this basically submits a build job. It builds the image in the cloud, and it saves this image in Google Container Registry, right? So that's what this command does. So I did that already, and once I have my image, then I'm going to run this command to deploy it to Cloud Run. So I will change the project ID to my ID. Cloud Run Atamel. So what I'm saying is that basically gcloud is the command line tool for Google Cloud. Beta is because it's beta. And then run means deploy to Google Cloud Run. And then I'm just pointing to my image on Google Container Registry that I pushed already. So once we do that, it says, OK, the service name is Hello World. Yes. And then it will create a revision, and it will route traffic to it, just like Knative, right? Just like what I show you. It does the same thing. It creates a new revision and it routes traffic to it. But I haven't created a cluster. I haven't installed Istio. I haven't set up cluster role binding. I haven't done anything. All I did is just deploy this, and it just deploys it for me. It's fully managed. And once this is done, it's already done. We can actually go to Google Cloud Console, and I will switch my project to Cloud Run Atamel. So this is my project in US Central. And then if we go to Cloud Run, you see I have some projects here, but the Hello World is the one that we just deployed. And you see under revisions, so you got a console for your application, and you can see that under revisions, these are the ones that I deployed, and you can see that there's one that was just deployed now, so it's the one that we just deployed. And it's getting 100% of the traffic. We can look at the logs if we want. We can, well, if it loads, usually it's fast, but it's in the US, yeah. So you can see the logs. So you can see my app is listening on port 8080. You can look at the metrics. So if someone calls your app, you can see it here. So you get all this by default by just deploying it on Cloud Run. You also get a URL, so you don't have to configure your domain by default. And you can also set up your domain with Cloud Run as well. But by default, it gives a dummy domain. And if you click on it, it won't be anything exciting. It will just say hello v1, just like before, but it's running in managed Cloud Run. So it's very similar to Knative, except you don't have to even think about the fact that there is a cluster underneath, right? So I just want to show you that quickly so that you get an idea how that works. So now I can switch back to my Knative project and go back here. And then let me switch back here as well before I forget. Because one time I forgot, and it was a disaster afterwards. All right, so that's, I show you Twilio, I show you Cloud Run, so we can skip that. So that's Knative serving. Next, I want to talk about Knative Eventing. And in a nutshell, Kinetic Eventing basically allows you to connect event sources to event consumers with some kind of flow in the middle. I know this is a very high-level description, but that's basically what it is. The event consumers are Knative services, and then you can do some kind of filtering beforehand that I'll talk about. And the event sources are basically a full list of things. So this is not the full list. The full list is here. But you can basically listen things like Apache Kafka. You can listen Google Cloud PubSub messages. You can listen GitHub messages. You can listen Google Cloud Storage messages. You can listen Kubernetes events. So there's a lot of things that you can listen to, and you can write your own listener if you want to. But in the end, this is how it works. So you have, in Knative, you have something called Knative source. This is the thing that listens the external event. So for example, if you're listening Google Cloud PubSub, it will listen PubSub messages. So you set up a source that listens the external event. Then it passes to something called broker. In the normal case, you would have a broker per namespace. So in your namespace, you have a broker waiting for messages. So the source will listen the message, it will pass it to broker, and the broker will pass it to something called trigger. The trigger is the thing that makes the connection between the broker and the Knative service. So eventually, your message will end up in the service, but the trigger in the middle will do some filtering if you want. So it will, for example, in the service, it only wants to care about this kind of message, so it will filter those messages, and it will only pass those messages. Or not. Maybe you don't want to do any filtering. You can just pass in every message to the service. But at the high level, basically, the source listens for the message, the broker gets it for the namespace, and then passes to the service via the trigger. So the events in Knative, they end up into something called cloud events, because these events, they can be any kind of events, right? They can be GitHub events, or they can be Google Cloud Storage events. But what happens is that when it gets into Knative, the Knative source will take those events and it will convert into something called cloud events. The cloud event is an open source CNCF definition of events, and it has some metadata like the ID and the time and stuff like that. And the data of this cloud event will have the actual event that you're interested in. So in this case, for example, we have a GitHub event, so the data will include a GitHub event. But eventually, everything will be a cloud event, and it will go to the broker, and from broker onwards, it will all be cloud events. And as I mentioned, the broker is the one that gets the event for the namespace. And then from the broker, it goes to trigger. The trigger does some filtering if you want, and then it will pass it to a Knative service that you define. And that's it. That's all you have to do with it. And I'm going to show you another example shortly, but let's do a Hello World example again. So for example, let's say we want to deploy an eventing example to listen Google Cloud PubSub messages. So what we're going to do is we're going to listen a PubSub topic and get that event into Knative, and then get that routed to a Knative service and just log out that message, right? Do something simple, like just log it out. How do we set that up? First, what you need to do is you need to make sure that Knative Eventing is set up, so we already have that. You need to set up a source that reads the messages, right? So in this case, we want to read PubSub messages, so we need to set up a GCP PubSub source. I already set that up, but let's make sure that it's running. And let me also go to eventing part. All right, so maybe I do it here. So the PubSub source, this testing source I already set up that's listening on an external Google Cloud PubSub topic. It's already running. And we also want to make sure that our default namespace, where I'm going to run this example, has a broker waiting for the messages. So if I do kubectl get broker, hopefully I already have that, yeah. And actually, if I do kubectl get pods, you will see that I have a couple of pods for broker that's already running, and another pod for the source that's already running. So these are the pods that are listening for the events. So that's why we have them running. And actually, I can also get rid of my service that I don't need anymore. kubectl delete, Knative service. Let's just delete all. Yeah, that gets rid of the Twilio one. So stuff is set up. Then what I want to do is I need to create a Knative service to actually log out the message. So the service, just to let you know, kind of looks like this. What it does is that it's very simple. When it gets a message, it just says the message dumper received the message, and it just logs out the content, right? It just logs it out. I create a Docker file, and then what I need to do is I need to create a YAML file for my trigger and for my service. So I push my message, and then in this trigger YAML file, I do a couple of things. The first thing is my service. So just like before, I create a service with the image, and the minimum scale I set it to 1 so that I always have 1 running. And then the trigger, in this case, I'm not doing any filtering, so any message that will get into my broker will go to my service, but the trigger is used to combine my broker with my service, so that's how I do the connection, right? So once we apply this, let's apply message number, kubectl apply trigger. And let's clear this. So that created the service and the trigger, and actually if you look at it, kubectl get pods, you will see that I have a message dumper pod already running, waiting for messages. And what I want to do is I want to look at the logs of this pod. So let's just copy this so that we can look at the logs. And copy that. So you can see that my app is just waiting for messages on port 8080, right? It's just a Knative service. Now to trigger this, I need to send a message to Google Cloud PubSub topic and get that triggered, trigger the PubSub message, and that will go to Knative, and then Knative will do the full chain. So let's do that. So to do that, I can use gcloud. So I'll just copy this. So what I'm doing here is that I'm saying gcloud PubSub topic, publish, and then the place I'm publishing to is called testing. So that's my topic, and the message is hello world, something very simple. So we do this, and now this goes to Google Cloud PubSub, and then from there it makes it to Knative. And you can see that here it says message dumper received message, ID, and data, right? You don't see hello world. Well, because this is a cloud event, everything gets converted into a cloud event, and the data is the one that actually contains the message. So if I take this is base 64 encoded. And if I do, I think if I remember correctly, base this and base 64-D maybe? Yeah, you see that if I decode it, I see hello world, so I receive the message. So that's how you make a connection from an external system to a Knative service running in Knative. Now, the next example I want to show you is it's a little bit more interesting. What I want to do is I want to combine Google Cloud Storage to Google Cloud Vision API. So these are two separate things that have nothing to do with each other, but you can use the loosely coupled infrastructure of Knative to combine them. So what I want to do is that in Google Cloud Storage, it's a place where you can store any kind of files. So I have a bucket for Knative. I created a bucket for Knative, and you can enable notifications from that bucket. So what I did is that I created a bucket to save some images. Then once I save an image to the bucket, it will send a message to a PubSub topic that I defined. And then I have Kinetic Eventing listen the topic. It will get that message, and it will pass it to a Knative service. And the Knative service will say, OK, I received this message that tells me that there's an image that's saved to this bucket. Let me call Vision API, which is a machine learning API, to analyze this image and extract labels out of this image, and it will just log it out to the user, right? So that's the flow that I want to set up. To do this, by the way, I have another example with translation API, but we don't have time for that, so I'll skip that, but feel free to look at it if you want. So in the Vision API, first I need to create the actual service that will do the Vision API call. So what we do in here is that first, my code has to handle cloud events, right? Eventually, the service will get a cloud event, so I do some parsing of the cloud events here. We don't have to get into details of that, but basically in the end, you get a cloud event. And then I need to look at the right cloud events, right? When you save an image, the type of the cloud event is called object finalize. So I'm just looking at those events that have the type object finalize. And then from the cloud event, I can extract the bucket ID, so which bucket this image lives, and the object ID, what's the name of this image. So I'm basically extracting those, and that gives me the URL of this image in Google Cloud Storage. Then I can call Vision API. So to call Vision API, I create a Vision client. So this is the client I use to make the Vision API call. And then I say, Vision client, detect labels async. So this says basically, given this image URL, extract the labels out of this image and give me 10 results, because I don't care more than 10. and then I will have some labels with some scores, because it's using machine learning, so it's not 100% sure. I take these labels, I order them by the score, and I just log them out, right? So that's my code. I create a Docker file, and then I create a, let me show you that. I create a trigger.yaml like before with the service that points to my code, and then the trigger that connects broker to my service, just like before. And let's actually deploy this and see what happens. And by the way, this is how you create a bucket, and this is how you enable a notification on the bucket, but we don't have to get into details of that. So let me go to Vision and clear this. kubectl apply trigger. And if you do kubectl get pods, so you see that it created my service and the trigger. And if you look at the pods, you see that I have my Vision pod running as well. Let's look at the logs just like before. But this time, instead of message dumper, I want to look at Vision. It's still creating, so hopefully it will be created now. Yeah, so it's waiting for messages. Now, what we want to do is I go to Google Cloud. I go to Cloud Storage. I already created a bucket for my Knative project, and I already enabled notifications on it. So the bucket is empty. So let's just upload a file and see what happens. So I go upload files, and find my tutorial, eventing, Vision, pictures. Let's send this picture. I don't know if you can see this, but it's basically a nice beach with sunset. Any guesses where this is? Anyone? No? Spain? No. Mexico. Close, but no. Chile, Argentina. Close, but no. It's Rio in Brazil. So I open this. Now this is being uploaded to a bucket in Google Cloud Storage. That will trigger a pops-up message to a topic, and Knative will get that message, and it will pass it to Knative service, and from Knative service make a call to Vision API. So if everything worked, which is a big if, it worked. So our code received the cloud event. The data is base64 encoded. From there, it extracts the actual message, and then it makes a call to Vision API, and in the end, it says this picture is labeled sky, border, water, sea, nature, coast, water, sunset, horizon, which is pretty good. But the point here, I mean, it's a very simple example, but the point is that you're connecting something like a storage event to a machine learning call using Knative in the middle. And the fact that this Knative, it lives in Google Cloud right now, but it can live anywhere you have Kubernetes, and that's the important part. All right, in the last 10 minutes or so, I want to cover Knative build, the boring part of Knative that we all need, you know? That's why I talk about it in the end. So Knative build, before I start talking, let me start some builds, and then we can talk about it as the builds are happening. That way we can look at some builds afterwards. So what I want to do is, let's kill this. And let me, no, I don't want that. So let's go to build, and then I have some builds here. Let me just kick some builds, and I'll explain what they are. So the first one is build hello world GCR. So this builds and pushes an image to Google Container Registry. The second one is a hello world to Docker Hub. So it will build and push an image to Docker Hub. The third one is it uses a build template with Kaneko and pushes to Google Container Registry. And the other one is a build template with build pack, which I really like. It builds a Java app and pushes to Google Container Registry. I think that's enough. And then if you do kubectl get build, you see that we have 4 builds that are pending because they're running. So once I explain it, hopefully they will be done, and I can show you what they did. So Knative build, it basically enables you to go from source code to an image in a repository. In a nutshell, that's what it does. And it gives you some primitives to work with. So you would start with a build object. A build object, it's basically one or more steps that you define, and they're executed in that order. You can use what's called build templates. So you can take your build and create a template out of it, and that way you can use it from multiple builds if you want. Or you can install someone else's build template and use it from your builds as well. And Knative comes with some build templates by default, and I'll show you one example of that you can install and use it. It's very useful. You have different kinds of builders to build different kinds of things, like containers. And if you need to authenticate, you can use a service account in your builds. That way you can push to places like Docker Hub where you need authentication. So that's what it is in a nutshell. And just to show you the examples that I kicked off. So if we go to Hello World build. So in this one, what I'm doing is that I am creating a build, so the kindness build. And this is the name of my build. You point to your source. So the source in this case is that I'm building my Knative tutorial, the Hello World example. And then you define your steps in your build. I only have one step here. It's called build and push. And I'm using something called Canico. Canico, it's an open source image builder that you can use in your Kubernetes cluster. So basically, you can use Canico, and it creates a pod that will build the image and push it to wherever you want. So in this case, I'm just pointing to Canico image, and then I'm pointing to my Docker file, and then the destination is where you tell it to push. So in this case, it's gcr.io, meaning Google Container Registry. So this will build it, and then it will push it to Google Container Registry. And then once you can look at the build, and you can look at the pods, actually. If you look at the pods, you will see that there will be some pods for the builds that we are having, and some of them are init, meaning they are running, and completed is the one that's actually finished. So that's a Hello World build. And in the end, once this is done, I'll show you. You can go to Google Container Registry, and you'll see that this is pushed. If you need to push somewhere like Docker Hub, you need to authenticate. And for that, you need to use a service account. So to do that, first you need to create a secret. So secret it's a Kubernetes construct where you specify your username and password, base64 encoded. And then from secret, you create what's called a service account. Again, another Kubernetes construct. The service account has a name, and it also points to the secret that you just created. So you apply both the secret and the service account, so that creates the service account with the secret. And then when you design your build, it's just like before. This build is exactly the same as before, except I have a service account name here. So now I am referring to the service account that I just created in Kubernetes, and this will authenticate me with Docker Hub. And the other thing that's different is the destination. So the destination here is not gcr.io, but it's docker.io. So that's how you can push things to Docker Hub. Now the next one I want to show is a build template. So right now we define our steps manually, right? But you normally don't do that. What you do is you either create a template or you use someone else's template. For example, we've been using Canico to build our images. Instead, you can actually install Canico build template. There's a template that's already out there, and you can just install it using this. And then in the end, once you have the template, you can take a look at it by just saying kubectl get build template and see which templates you have. So once you have this template in your cluster, what you can do is you can go to your build, and you still point to your code and everything and give it a name just like before. But instead of doing the steps manually, you just point to a template. So in this case, I'm pointing to the Canico template. And the Canico template, it asks me, where do you want to push this image? So that's the name image. And the value is Google Container Registry. So that's how you could use a template from your build. So the rest is pretty much the same. And the very last thing that I want to mention is the build packs. Anyone here heard of or uses build packs? No? Oh, cool. So build packs, I think they're really cool because, I don't know you, but at least for me, creating an optimized Docker file is quite challenging because you need to kind of be a Docker expert to be able to figure out what you should use, how, and in what order, and what you should put in your container, all that kind of stuff. What build packs do, it's an open source project, is basically it looks at your code and it tries to create an image out of your code without you having to create a Docker file, right? So you don't have to worry about creating a Docker file. Build pack does that for you. That's the whole point of the project. And the cool thing about Knative is that there's a template for build pack that you can install. So you can install the build pack template like this. And then in your build, when you build your source, so in this case, I'm building a Java application, right? In this Java application, if you go to there, you'll see that there's no Docker file, just a plain Java code. And then I'm pointing to my template, build pack template, and I'm just saying push this to Google Container Registry. what it will do is that it will use build pack to detect my code, and it will create, I guess it will create a Docker file for me, and it will push it to Google Container Registry without me having to worry about Docker files myself, which I like, because I don't want to deal with all the complexities of Docker myself. So that's what we did here. And very last thing is that if you want to set up your testing so that you have a service, and every time you change your service, it kicks a build and builds it and deploys your service, you can do that. I won't explain it here, but basically I show you how to do it here. So automatic deploys are possible as well. So if everything worked, let's take a look. If you look at pods, they're all completed. If you look at builds, they're all succeeded. And just to prove that they actually worked, let's go to Google Container Registry. And this is Hello World app. You can see that this was pushed 2 minutes ago by Canico. So this is the Canico template. And this was pushed 3 minutes ago by build. So that was the first sample. And if you look at Docker Hub, under Hello World, hopefully that worked as well. You can see the Hello World, and it's hard to see, but this was sent by build 4 minutes ago. All right, I think, let's see if I have anything else. Yeah, I think that's all I have. Thanks for listening. If you want the slides and the code and much more than what I showed here, it's on Knative tutorial, and this is a QR code. Knative has a new page, knative.dev, with more information and samples. And I think we have like 4 minutes for questions, so I guess I can take like 1 or 2 questions if you have any. Thanks very much. So any questions before I go? Anyone? No? 1, 2, yes.
Yeah, so Cloud Run is not available in Europe yet?
Not yet, but it will be available like really soon. 'Cause we are alpha testing it basically.
Okay.
Yes.
Where do I sign up?
You'll see it on the web page soon. Like there's no like private sign up or anything like that right now. Yeah. All right. I'm gonna be at the Google Cloud booth, so feel free to stop by if you have any other questions there. Thank you.